this slide, the situation would dramatically change, especially for new build airports or terminal extensions. Because optical LAN supports large distances, there is no need any longer for mid-span electronics, and consequently the need for closets disappear. As you can see over here, there is no need for any closet anymore. So this allows airports to prepare a design that is much more focused on passenger experience and ability to monitor space rather than use it for IT equipment storage. And instead of deploying a switch in a closet, an ONT would be deployed, which is shown over here, either above ceiling, wall mount, or other deployment options. So over here to the left side, I have depicted a situation for an existing airport that has already Cat-X cabling in place, where the switching equipment can be replaced by an ONT, a 24-port ONT, for instance, and the Cat-X cabling is being kept intact because it's utterly complex to change the existing Cat-X cabling towards fiber cabling. The removal of mid-span copper-based electronics would also remove the needs for air conditioning. So effectively reducing the amount of overall power consumption over the airport LAN system. And last but certainly not least is the impact to cost. No longer there is a need to use switches, air conditionings, MDFs, and excessive Cat-X cabling. This has an immediate impact on TCO for the airport, which we will show later on in a little bit more of detail. So in summary, the support of long-distance passive connectivity translating to airport benefits in terms of TCO, airport design, monetization opportunities, and sustainability. So, as mentioned before, with passive optical LAN, the airport is able to significantly reduce in power consumption compared to copper-based LAN. Airports can vary a lot in terms of size. As such, it's quite difficult to come up with a single statement around power consumption savings. However, in general, we experience roughly 40% of power consumption reduction compared to traditional copper-based systems. This reduction is possible by removing the large amount of mid-span switches at the airport, as well as reducing the amount of air conditioning systems that are required by these switches. Such reduction in power consumption is of key value to an airport that is continuously being pressured on cost reductions as well as becoming a greener airport. And by removing the need for closets that hold copper-based switches, passive optical LAN allow airports that consider new build to optimize on passenger experience and maximize monetization. LAN connectivity to the endpoints will be as close as possible, as is shown on the picture in this slide. The ONT connects end equipment via Cat-X cables to the optical network, which in turn connects to the main airport data center room, which is depicted over here. No longer exists the limitation of a maximum distance of 300 feet or 90 meters from the closet. This allows for a much more flexible design of the airport, and earlier engagements with airports have shown a gain of roughly a floor space gain of 4%. This may not sound too much, but in reality it's significant for an airport if they can optimize 4% of total footprint in their airport for additional retail, for additional concessions and what have you. Now, as mentioned before, the TCO of a passive optical LAN network is much lower compared to a copper-based infrastructure. The savings range from CapEx, which are the infrastructure costs and elimination of site equipment, such as air conditioning and the MDFs that I talked about, as well as OpEx. This includes maintenance costs, power consumptions, etc. So the cost example given in this slide here is based on CapEx hardware comparison only between Nokia optical LAN solution and a competitor copper-based solution. Now, as can be seen, roughly 50% of CapEx savings have been reached in this particular example using only a 4-port ONT. Now, let's talk a little bit about the passive infrastructure of Nokia's optical LAN solution. So the graphic to the left of this slide shows the cable room that holds splitters and an optical distribution frame, all mounted in a compact space in the ceiling. This particular installation allows for an installation of what we call a 3x32 split, serving in total 96 optical network terminals, or ONTs. This translates into a minimum of 400 Ethernet ports. Now compare that what you would need in terms of a CAT-X solution to address 400 ports. To the right, you already see this thick CAT-X cable, and you would need additional racks for the MDF to do all the patching. You need the racks for the switches and what have you, and of course what I mentioned about air conditionings and fire suppression systems and what have you. So, as said before, passive optical LAN reduces the amount of space required at the airport for IT equipment, and consequently, airport architects and consultants can minimize the impact of the LAN infrastructure to a better aesthetic design, with small bundles of fiber and removal of fiber or airport closets. Space planning becomes so much more streamlined compared to the traditional solutions. The use of fiber instead of CAT-X also introduces an effect over the longer term. Fiber is able to support terabits today, whilst copper cables are limited to just gigabits. So today we see new technologies emerging at the airport, such as Wi-Fi 6 as well as 5G. So passengers will be increasingly connected, and bandwidth demand has been up for years on end. Now in time, airports will be faced with new technologies such as Wi-Fi 7 and even 6G that will ever increase the need for an infrastructure that is able to cope with such demand. Replacing a passive infrastructure at an airport comes with huge costs and complexity, since thousands of assets are connected and depending on this LAN network. With optical LAN, the passive infrastructure can stay in place because it's fiber. For sure, the electronics will require an upgrade to support these higher throughputs. However, the impact and costs involved with upgrading electronics is significantly lower compared to replacing a CAT-X cable infrastructure. As such, for sure, investing in fiber for a LAN infrastructure is an investment protection for the airport. Now, the number of subsystems at an airport is quite substantial, and it is even expected to grow whilst airports are increasingly digitalizing their operations and ability to become more operationally aware. Nokia Optical LAN is able to connect these subsystems to the network. And as we will see later on in the reference slide, Nokia has already connected many of the subsystems that are shown in this slide. One subsystem may call for higher service priority than the other subsystem. Nokia Optical LAN allows for different QoS settings between all of these subsystems. And as such, even if the system gets saturated or the networks get saturated, Nokia Optical LAN will ensure that those services like surveillance cameras or door locks, when I would hit my swipe card or key in my code, will just continue to operate. Some of the airport subsystems will require Power over Ethernet, or PoE. Nokia's ONTs will provide PoE to those airport subsystems that require Power over Ethernet. Nokia also has solutions that allow for backing up Power over Ethernet in case of a power failure at the airport. And this is very important to remember, because typically when you are in front of an airport, you will be challenged how to back up the power in a passive optical LAN network, because the existing systems are all being backed up from the closet, where there is a UPS in the closet, and Power over Ethernet is being backed up by this UPS. Now with our solution, we have solutions available with a smaller UPS that can be installed together with the ONT to help back up the Power over Ethernet subsystems. Now let's discuss service reliability as well, because this is a very important topic to the airport. Nokia Optical LAN is rooted in the telecommunication industry. What this actually means is that the system performance is carrier grade, meaning that it is designed to support service availability of up to 5x9. Networks like optical LAN tie into many of the systems that airports rely on, as I just explained. So it goes without saying that airports will want the passive optical LAN network to be highly resilient. With Nokia Optical LAN, all of those airport subsystems can be connected over the same infrastructure and ensure service reliability. The Nokia Optical LAN comes with various redundancy options in order to ensure the right service availability levels are being reached. This ranges from, which is depicted over here, intra-chassis redundancy, protecting the various fiber routes, or full geo redundancy network architectures, which will protect the components as well as the fiber routes. In addition, the solution supports redundant power feeds as well to further enhance system resilience. So obviously, not all the subsystems may require a full redundant architecture. And Nokia is working closely with the airport to understand the exact requirements in order to ensure the best architecture is designed in the most cost-efficient way. Another important topic to airports is security. So Nokia, first and foremost, Nokia products are designed around security. And all of our products are subject to our what we call DAFSEC, or Design for Security process, where we ensure that security is well embedded in our product lifecycle process. Different from the traditional copper-based solutions, Nokia Optical LAN also comes with built-in military-grade AES 128-bit data encryption. Also, Nokia Optical LAN management system allow users to configure fine-grained controls to ensure that only those who are allowed to access specific commands or parts of the network will get access to this. In addition to that, the Nokia ONTs are based on what we call thin client devices, avoiding that unauthorized access from the ONT can lead to a security breach. Now let's discuss priority service differentiation. Maybe a little bit of a complicated slide, but let me go through that. So Nokia Optical LAN has built-in QoS as well to allow airport operators to assign the appropriate service priority to the various subsystems. Nokia is following the GPON standards with respect to QoS implementation. However, ensures that the implementation is done in such a way that QoS setting at the management system removes complexity to the end user. QoS setting can be done on a per ONT basis, or on a per port basis, or on a per VLAN basis. QoS settings are done in both the uplink and downlink direction, and in uplink the traffic can be tagged with 4 different QoS classes, as can be seen on this slide here, which is over here. Nokia's implementation of traffic shaping ensures that the traffic is treated in accordance with its priority. Now in the downlink direction, traffic is already priority tagged, and the optical LAN OLT will have to treat the traffic accordingly. Nokia's OLT performs so-called hierarchical scheduling to cope with the various traffic types and priorities in the downlink. Now, in principle, this could be a very complex topic to discuss, and you may be challenged in front of an airport to explain the priority settings in a passive optical LAN system, because traditionally airports are being used to the traditional switches, the copper-based switches. Of course, we have our experts from within Nokia that can explain this in a lot more detail and convince your client that passive optical LAN is better or even at par with the copper-based switch solutions. Now let's move to the management system, or the operations. So Nokia Optical LAN provides substantial savings on management and maintenance costs, because all airport optical LAN networks can be managed from a single central location. Nokia's name for the optical LAN management system is called POL Command Center, or PCC. The PCC is effectively taking away the complexity from the user in order to ensure services can be configured in a simple way. In fact, Nokia's PCC is a differentiator in the market when it comes to simplifying the management of an optical LAN network. Such approach can form the basis for an airport operator to consider monetization of connectivity services inside the airport. Simplification of service creation, the ability to set priorities in a simple way, the segregation of traffic to ensure operations isn't impacted are just a few capabilities that allow airports to consider such business model. The PCC provides various levels of network insight. One important aspect is to easily navigate to the various ONTs that are being deployed across the airport. In case an alarm is being raised, the PCC provides what services are being impacted, what ONT is being impacted, what is the exact location of the ONT, and which OLT and line cards it connects to. Another example of the PCC taking away complexity is the ability to predefine services for the airport. Examples could be a digital signage service, which could be on a template, or high-speed internet towards their clients. That could be retail or concessionaires or restaurants, or there will be another service called surveillance towards the security people in the airport. All of these services can be predefined and quickly implemented whenever a new service is needed. In order to integrate the PCC into an existing airport system, the PCC northbound interface features APIs that allow for service provisioning, inventory snapshots, network fault views, and what have you. As mentioned earlier in the presentation, the PCC also addresses security in an effective way. PCC features role as well as resource-based access control. Such methodology ensures that the airport IT staff can only access those parts of the network that they are allowed to, and restrict access to predefined roles such as admin or designer or observer. Now, although today airports are faced with a really tough time in terms of passengers traveling, the pre-COVID trend was clearly showing a year-over-year rise in passenger count. And with airports continuing to cope with that rising demand after the COVID time, the infrastructure, both physical and IT related, has to grow accordingly in a cost-efficient way. With Nokia Optical LAN, airports can grow in a cost-efficient way regarding the LAN infrastructure. First of all, passive optical LAN is developed in such a way that it's cost-efficient with a small number of ports to 10,000s of ports. The electronics can be scaled accordingly to the needs of the airport. As such, the system grows with the airport, driven by the number of ports and or the capacity needed. In addition to the GPON systems that I just explained, Nokia also has developed the next evolution to GPON, which is called XGS-PON, supporting 10 gigabits of up and downstream performance. Under development is a 25 gig PON system supporting 25 gig up and down. And although this development requires different electronics, it's important to remember that the passive fiber infrastructure stays as is, proving it to be a true investment protection for the airport. And with this, I'd like to hand it over to Thomas.
Yeah, thank you, Richard. Let me just take control here. Yeah, now it works. Okay, so hi, this is Thomas Rehberg. I'm heading the aviation segment in Digital Industries, and I'm taking you now to the last part of the presentation, which is about the how to sell. And how to sell, this starts with how to engage with our customers. Now, before we go there is one thing that is special on POL. which is that you could find two different scenarios if you talk to airports about that. One being the brownfield, meaning that this is an existing airport which is looking for extensions or anything else, but there are also greenfield scenarios, greenfield projects where new airports will be about to be built. Now on the brownfields, this is, by the way, what we normally find. There is the Chief Information Officer, also his colleague taking care about the technology, the CTO, which are, of course, decision takers, and we need to find them. But there also are Chief Digitization Officers. More and more airports will have that role, just as a consequence to them also quite aware that they need to go for the digitization big time. They need to go and start that journey to the Airport 4.0 principles, accompanied or just complemented by the head of innovations who is driving the processes to get something with more efficient gains, etc. And there are as well the people that are having their hands day by day on the networks, the directors of network infrastructure or ICT architects. These are the typical roles we need to identify within the airport organization. Some of them are always existing. All of them you will not find probably unless you talk to a very large airport. But these are the roles that are of importance. And then in addition, when we talk about greenfield scenarios, there is one very important role that comes in addition, which is the airport consultant, the design authority, the people or firms that are in charge at project state to put in place a design which is state-of-the-art, how an airport today should look like. These are very important for us because we need to make sure that we are talking to them at the earliest stage possible where the design is due, so that every benefit that is provided by this solution goes right into the original design, because then it is the place where we can play best. You might ask yourself, so why on earth you guys are talking to me about new airports given the difficult situation in aviation? But in fact it is true. We still have more than 120 new airport, greenfield airport projects that we know about, and about 250 or so brownfield extensions that are available. That do exist, globally speaking. We have also a list of them, which you will find in that Excel sheet here attached to the slide. So once you download them, you will have access to it. You will find them, some of them coming within the next year. Some take more time to come, obviously, but they do exist, and you can look into your region, able to find them and try to get hold of them and talk to them. Now, a bit more into that greenfield first. A greenfield, what can it be? It is obviously a new airport or a new terminal at an airport. Some airports do extend their campus size or to build new terminals. From time to time also you see more airports, airport builds at the same campus for admin, for hotel, for cargo. Cargos are typically coming at a size of another airport from time to time, because they are running very large hangars and storehouses, warehouses, give it a name. All of this you see happening at greenfield projects. And POL, why POL? It's simply like Richard explained, it is because cost savings from the very beginning. It's just obvious that you need fairly less space in the design, less space in floor channels, in windowsill channels, ducts, whatever you want to have, and that saving in space is to the benefit of what the airport can do to improve the PAX experience. They can have more space assigned to dwell time of the passenger, for shops, for retail places, and by this increase their non-aeronautical income. They are heavily depending on this. No airport is really happy with what they can get just from the airlines for the airport operations on the airside. All of them are highly depending or non-aeronautical income, and it just provides them with more space to do so. Also, all these greenfield projects will have received strong targets about carbon footprint reduction. The green movement is across the globe, and yeah, this technology just fits nicely into the zero emission policies when the airport also has to show back to the government that they do take care. All in all, it is also an investment protection. No one wants to invest in new infrastructure when there is not just a future-proof granted, and this is a given when you select this technology. On existing airports, though, so if we now leave the greenfield and look into the brownfield, they do have obviously an IT LAN infrastructure, but in a lot of cases, this is really a pretty old IT infrastructure. It needs renewal. Maybe also they decide to keep it like it is and invest in something new in parallel, because there are more applications like surveillance coming to their desk, and they just don't get the point to further invest into that existing legacy infrastructure. Better build something new, and this is then separated from all the rest of the applications. Also here, the cost savings are very attractive, same as with the carbon footprint reduction. And also here they can save space. They can retire existing closets wherever they were needed at the terminal. They can open the space for also here the PAX experience or shops and the like. It helps them to better dispatch the available space at the airport for things that they need on the non-aeronautical revenue stream. The technology as such, so the USPs is a bit of a repeat what Richard explained, but here let's run it through again. We have obviously lower TCOs, both on CapEx and on OpEx, provided by power, space, and maintenance costs, so just significantly lower. It helps to reduce the part of the airport space that is just occupied by IT gear. On the security side, we are meeting military standards with this. All the airports, they will not talk about it easily, but just be aware they are a typical target for any kind of cyber criminals. You won't read this in the newspapers, but it happens almost every week. So to offer them something which is just military grade is a strong point, combined with the investment protection and the contribution to the airport sustainability on low power consumption and their contribution to green. It's even for them then nice to show this also to the authorities that they do care about the green airport policies. We are strong in the technology. Nokia really has a say. We have an enterprise-focused management system which is built for enterprises, meaning that it takes away complexity. We are not confronting them with something that is built for carrier specialists. They don't have the teams of this size. And it's thought through. It's easy for them to provision these services and also to take care about their tenants at the airport and other clients. It helps them to make sure that the investment they do are protected. Our technology here, our product has a 100 gig backplane support, so we don't think that really can come to any limits because we are a leader. We are a global leader in fiber technology and also on anything which is about GPON. We have shipped more than 100 million of these ports across the globe. And this, of course, you see also in the way we are positioning ourselves here and how our portfolio look like on the POL side. We are the networking guys. We know how to do this. Then the one-page summary. This is what you need to know before meeting the decision takers that you might meet even in the elevator. Now, the mega trends, as explained by Richard, the airports are in the midst of that Industry 4.0 wave. They have to take care. They need to do something about digitalization. If not, they would just repeat the legacy processes, restart them again, and they will continue the same way of working when the traffic is back, and they will face the same cost challenges. This translates into an increasing use of modernized technology on the platforms, but also on the network. Their need then is to have a solution ready which is helping them to lower the TCO. They are very short in money in these days, so anything they do invest has to improve their cost lines directly or indirectly by a reduction in IT space, and it has to allow them to monetize what they invest. They have also a role of a landlord at the campus. They have clients, other tenants, and they need to make sure that anything they do for them, they also can make money with. And all in all, of course, anything they do, they don't want to see any technical limitations already visible when taking the decision. So the bandwidth increases is to be met by the solution we offer. And all what they are in need of is exactly translating into our value. Anything which you connect at the airport via this network is just connected in a cost-efficient, secure, and reliable way. It eliminates the widely spread technical infrastructure where you have airport closets across the terminal you need to take care of to get rid of them. You can add this additional space to your passengers and look for further monetization. We have a right to win here because we have done it already, and some airports have decided to take this technology and they are quite happy with it. They applied it to the airports, to hotels sitting at the airport, or to admin buildings, and they are already in the middle of just getting or harvest the benefits of reduced complexity and of simple service creation. We are a party of trust. Nokia has strong references. Nokia is a company that is further investing in innovation. We are part of the ecosystem, I should say. We are highly committed to it, and we are also participating and be a member of all the associations that are knowledgeable, as per the first slide that was presented by Richard. So there is another slide I wanted to show you here. This is because the slide that I just left, this is not the one you want to take to your customer with. This is fairly too complex. That's for you, for your briefing, so that you need to make sure that the messages which are on this slide here will come across when you talk to your customers. This is just a skeleton that we offer to you if you are preparing yourself for your presentations with the customer. You can add the details or the localization as per the need, but with the slides available, then you make sure that all the main messages will be on that slide. About the references, as said, we've done it already, both on greenfield and brownfield. We have up to 7 airports that have already decided to introduce POL. The subsystems they have connected to are on that slide on the first line. One airport has decided also to connect the administration buildings to it. We have another airport that has decided to make use of this technology for a hotel, which is in his property, sitting on his campus, and now it is running all the internal communication via POL. We have MROs that have decided for their technology for their back offices, for their training centers even, to just make sure that everything works as it should be. And also some airlines that introduced the technology already. So that's a small part of the more than 300 global references, but we are already visible in that part of industry called aviation. And with these references in hand, we are in the belief that we can do much more because it nicely fits to what an airport will need. Last slide. This is a slide for reference, for information, where you find it, what are the names. Richard and myself, you heard today talking in the GRTS session. We have colleagues of us taking care about the regions. You see the name here in the box in the middle of the slide. There is a lot of material already available as collaterals. If you want to make use out of it, by this link you will find them. It's the value proposition you will find there, and also a brochure that you can just use and send it to the customer to gather his interest and a lot more is at the internal and external sites that are as well on that list here. There are more events coming. Just to point out, there will be a POL webinar, an external one, May the 19th, where you can bring your customers into this. It will be an external webinar we will do, Richard and myself, at May the 19th. And also for the partners, there will be sessions done so that also our partners can just receive all this information we are sharing with you today. POL is an instrumental part of the strategy that we have to do business with airports. It goes twofold. We have a wireless offering strongly around the private wireless ideas. And on the wireline side, POL plays an instrumental part for the reasons explained, but also in combination with private wireless. And with this, I'm at the end of my session, and I'm handing back to you, Alison.
Great, thank you, thank you. So we'll move now to the Q&A. Sunil, I know you've been answering some of them as you go along. If there's any that you haven't answered or any that you'd like to highlight, please do.
Yes, thank you, Alison. So I have here a question, so I will take that one. So it's I haven't heard anyone mention that another benefit of Nokia Pulse solution over copper is that copper is very heavy and requires physical supports to hold up cabling, in ceilings, etc., whereas fiber is a very lightweight and can be installed just about anywhere. So optical LAN solutions, deliver significant TCO savings, both in capex, so with much less equipment, because you only have one active element in the optical LAN, which is your OLT, and it also reduces significantly the amount of cabling. That is correct, but it also reduces the operating cost because of the fact that the equipment requires less power, less cooling, also less maintenance. Again, the OLT, or your central switch, is your only active element that requires maintenance. Another benefit is that one can manage the entire network from one central location, so it's centralized control. So you have to manage the OLT, and in turn the OLT manages or controls all the ONTs. So that is a benefit. It's highly scalable. So we have different form factors supporting up to 8,000, 16,000, and even 32,000 endpoint devices. And then maybe the final benefit that I want to highlight here is that upgrades to next generation technologies are very simple and cost efficient, because in the case of an optical LAN, rip and replacement is not necessary. So you can reuse your central switch, the fiber optic cabling, as well as the splitters for any evolution to next generation technologies. And there were a couple of questions that I think, Richard, you are in the best situation to answer them, but I'm afraid that I cannot scroll up. I cannot see them again. Are you in a position to scroll up? Yeah. Okay, I have it here. Just a second. Just a second. Yes. The question is, do we have any partnership with investment companies who can build a model for extra non-aviation revenue for multiple years to replace cut structure? Interesting question. Let's see. Investment companies, I'm not sure to understand why especially investment companies, but we are having contacts with consultants who are and design authorities that actually determine what kind of a solution will be inside the, for instance, a new built airport. So that's one of the challenges that we face as well. I mean, we need to be very early to the game when it comes to the introduction of passive optical LAN in a new built airport or new built terminal. So we work with consultants, and once consultants are being convinced, we are in a better position, of course, to more easily insert this into a new airport construction. I'm not sure whether that answers the question, but okay.
Okay, Richard, I have here another one, also very interesting. So this one is related to security. So it says the security of an airport's network is important, but they can always rent the network to an MNO and use the available frequency bands, thus avoiding the cost of deploying a full dedicated network. So what are the advantages? Okay, just a second. What are the advantages? Yeah, what are the advantages of our Nokia solution in relation to the rental of the network of a mobile operator already installed at the airport, often using a DAS system shared between several operators, including safety nets such as Tetra?
That's a long question. All right, so let me try here. So airports are a bit conservative, right? Certainly inside the terminal, the conservatism is that a lot of things are still being connected. A lot of subsystems are still being connected over wire, because that's what they trust. So it takes a while before the airport starts to decide to have their critical subsystems, which they will completely rely on, to put them towards a wireless network, be it a DAS, which is in fact indeed a public wireless network, or a private wireless network which is being deployed at an airport. And we are in discussions with the airport to actually deploy a private wireless network inside the terminal and gradually connect subsystems towards the private wireless network. The challenge with connecting subsystems to over a public wireless service, which is offered over a DAS network, is that it's a best effort service. So there is no guarantee on capacity. There is no guarantee on priority at all, because it's a consumer service, a best effort service. So airports will be very careful in deciding what they will connect over wireless and what wireless technology should be used for that. But for now, I would say the majority of the subsystems we connect inside the terminal are all being wired up. Most of them are all being wired up. We move to a wireless situation on airside. It's the outdoor situation. But inside the terminal, there is still a lot of wireline technologies, and it will be there for years on end.
Okay, thank you. So then there is another question which I will take, and that is, what is our advantage over Telops or other competitors? Well, first of all, our main competitor, or global competitor, is Huawei. So with their Agile Pulse solution, which is more or less at par with our Nokia Optical LAN solution. Now, when we compare against Telops, the first thing I would say with Telops is that they don't scale to support or to be a global organization. So it's their activities are mainly in North America. And what I've seen with Telops is that they tend to overcommit or over-market some stuff. They like to talk about software-defined networking, but whenever you ask or whenever they have a presentation or a webinar and questions are then asked about, okay, explain this software-defined networking solution, then they have to say, well, it's not available. We can develop it when there is a demand for it, etc., etc. And then I would say the key advantage of our solution is the PCC. Really, the ease of use or the ease of management of an optical LAN solution with our PCC solution is definitely the key differentiator here.
Looking for other questions.
If you mind, Shamil, I'd like to highlight one question that is already answered by you, and that is the question, CCTV requires multicast to be implemented in the network, GPON supports multicast by nature for downlink, but CCTV is required in the uplink. How is it implemented by Paul? It's a very relevant question, and Shamil, you already answered that. CCTV and other services are transparent for optical LAN. And to further emphasize that, our biggest contract with an airport Paul network today is with a CCTV surveillance network, where we have deployed over 2,000 ONTs, 4-port ONTs, in Asia Pacific to a gateway airport. That is solely dedicated to just surveillance. So the only device that is connected to this network is a CCTV camera. So that proves that we already are deploying this over a passive optical LAN network. And we're talking, since we're in the sales community here, I mean, we're talking 900K of a contract here for such network. So usually, I mean, passive optical LAN is sometimes perceived as a solution which brings in little money, but this proves that if the airport has a large enough deployment, and we have multiple of them, there's significant money attached to a passive optical LAN solution. Absolutely, because there are thousands and thousands of subsystems that need to be connected, which will require lots of ONTs.
And then maybe a final comment from my end. So really, when comparing optical LAN with switches and cut cabling or managed switches, it is really important to emphasize or to focus on the TCO savings, on the total cost of ownership savings, and not only compare active components or the cabling, but it also involves the OPEX savings that can be realized, as well as floor savings. So really, it's one has to look at it holistically. The total cost of ownership savings, that is what how we should pitch an optical LAN solution to our customers. And currently we have over 300 references globally, and what we've seen is that the total cost of ownership savings are anywhere between 20-25% to even 40-45% with an optical LAN. And Richard, I have one question for you. One more question for you. Just a second. I have issues with scrolling down. Sorry.
I see there is a question open. Do we have references where we paired passive optical LAN with a private wireless solution?
I think that's the one.
Yeah.
Yes, that was the one I was referring to. Yeah.
Yeah. So let me answer that one. So currently we do not have references where we pair that, simply because typically airports procure in a way that they either look at a LAN refreshment, and they procure that part of the business, of the infrastructure, or they look into, for instance, private wireless business. Typically, we start off with airside deployments to outdoor deployments, and we may come across a case with passive optical LAN connectivity towards the private wireless network. But until today, I mean, we haven't come across the combination of technologies. But that may come as we will further deploy. Yeah.
It's also a phases problem, right? Yeah. So typically, you don't have an investment need for the two of the subsystems at the same phase. So. But this might change. It's just that, specifically on the green field sites, one could expect that it's addressed in one go then.
There's one more question open, I see. That is the question, do we know what percentage of U.S. airports have implemented POL? It's a very interesting question because we see the U.S. as one of the fastest moving markets on passive optical LAN towards airports. Although I do not know exactly what percentage of U.S. airports have already implemented that, because many of the projects are under NDA, and we simply don't know. But we know that a number of public airports, like Orlando, like Chicago O'Hare, like LaGuardia, like DFW, they already have passive optical LAN implemented into their airport, connecting up to many subsystems. Unfortunately, we are not yet part of that. We are bidding with some of the airports, but we need to grow that accordingly. And so that's why we're also setting up these GRTSs, as well as public webinars for airports and private partner webinars, as Thomas indicated, as well, for partners.
I think there was a question coming in lately about POL and AirScale.
Okay.
Very last on the list.
Okay, I can take that one. So AirScale, if Indo Nokia technology, I mean, if one refers to 4G LTE or 5G small cells with all-in-one, an integrated antenna, integrated antenna radio unit and baseband unit, then I would say yes, an optical LAN is the ideal infrastructure to backhaul all that traffic, because in the case of this 5G small cell all-in-one, there is no CPRI traffic, so it's all IP Ethernet traffic that can be very easily backhauled over an optical LAN solution.
Mm-hmm. Yeah, and by this I think we reached the top of the hour.
Alison?
Timing. Perfect timing. So thank you very much for sharing this topic, Richard, Thomas and Samil, of course, for answering the questions. Thank you everybody for joining. I hope you'll join us again soon for another session. Thank you.
Thank you very much.
Everyone.
Thank you. Bye.
Goodbye.